This is the presentation for the beginning of Chapter 6 using similar polygons. So what we're going to start studying in this chapter are polygons that are similar to each other. And we've talked about congruent triangles, and congruent is different than similar. So what we're going to do first is we're going to take a look at what's exactly different between figures that are congruent and figures that are similar. So first of all, before we get into polygons, remember that a triangle is a polygon. A triangle is the least number of sides for any polygon. And when we talked about triangles being congruent, they had 6 congruent parts. There were 3 sets of congruent angles, and there were 3 sets of congruent sides. Similar triangles are different. Similar triangles have 3 congruent parts, which are the angles. The angles are the ones that are congruent. And then it has, they have 3 proportional sides. So the sides there are not exactly the same length, but they are related to each other in a scale factor. And we have a difference in symbols. So congruent means same size and same shape. And we have the little snake here with an equal sign. Similar triangles have just the snake. There's no equals there. Notice the symbol is different. And what that means is that it's the same shape. So if it's a triangle, it would have the same shape of a triangle. But basically what's different is just the size. So similar figures are the exact same shape, but they are just different sizes of the same shape. So let's take a look here at a quadrilateral situation. So I have quadrilateral ABCD, and I have quadrilateral EFGH. So the angles will be congruent if the figures are similar. So angle A and angle E will be congruent, and you'll notice that's in purple. Angles B and F will be congruent, and you'll notice those are in yellow. Angle C and angle G are congruent, and you'll notice those are in green. And angles D and angle H are congruent, and you'll notice that's in blue. So the angles will all be the same, but the sides will be what's called proportional. So they'll be in the same ratio for each side, and they'll go in corresponding order. So segment AB here in purple will correspond with segment EF. Segment BC in yellow will correspond with segment FG. Segment CD in green will correspond with segment GH. And then segment DA in blue will correspond with segment HE in blue as well. So in this case, the sides are proportional and the angles are congruent. So we talked about those proportional sides, and what they all are going to do is basically reduce to something called a scale factor. And the scale factor is just basically the ratio between the two figures. And all side lengths are going to have that same ratio, although the lengths of them may not necessarily be the same, but the ratio or the fraction that corresponds with them will be the same. And we use scale factors all the time. If you've ever looked at a map before, then you're looking at something that has a scale factor. You're looking at a much smaller version of what the Earth is in real size. Architects use them all the time with blueprints. And if you've ever played with Matchbox cars or Barbie dolls, then you've dealt with a toy that's got a scale factor. The Matchbox car, the Barbie doll, is just a smaller version of a person or of a vehicle. So let's do this mathematically. So when I'm looking at this statement, this reads as triangle ABC is similar to triangle DEF. So I'm going to say that again so you get that. Triangle ABC is similar to triangle DEF. So this symbol here means similar, okay? So the angles that are going to be congruent are going to be the ones in the same corresponding position. So angle A and angle D will be congruent because they're both in the first slot here in this statement. Angles B and angles E will be congruent because they're in the second slot in the statement. And then angle C and angle F will be congruent to each other because they're in the third slot. So that's going to look like this. And then the ratios of the corresponding side lengths. So, and again, we're going to look at the similarity statement. This is a similarity statement, and this is what drives the similarity situation. So in this case here, I have segment AB with the black and the red here is going to correspond with segment DE with the black and the red. Segment BC with the red and the green is going to correspond with segment EF. And then segment AC with the black and the green is going to correspond with segment DF. And that's then going to look like this. And then because these are similar, the ratios are all going to reduce to the same number. So these ratios are all going to equal each other. So let's look at it mathematically. So in this case here, I want to figure out x. I want to figure out what is this unknown value. And the way I'm going to use, or whether I'm going to do that, that's kind of dark. Let's try a little lighter. So the way I'm going to use this is look at the scale factor. So the side length that has x is segment BC. So that's these two right here. So the side length that I'm going to look at on this triangle to see what corresponds with x is going to be in the second and the third slot, which is going to be HJ. So in this case, x is going to correspond with 16. And then to try to figure out a ratio so I can solve the actual problem to figure out what x is, I can take a look at any other side lengths that have numbers. And every single other side length here is numbers, so I can use any other relationship I want. I'm going to pick the smallest one just because that'll be easiest. So if I go with x and 8, on here the shortest side is 12, which is BA in the first and second slot. So the shortest one in this triangle here is going to be 8, which is H and G, because those are also in the first and second slot. So when I go to set this up, then I'm going to go BC, which is x, over HJ, which is 16. That's going to equal AB, which is 12, over HG, which is 8. So that sets up this ratio, or I'm sorry, proportion right here. And then I just fill in the numbers. So BC is x, HJ is 16, AB is 12, HG is 8. And then in order to solve this proportion, I cross multiply. So x times 8 is 8x, and 12 times 16 is 192. So I get 8x equals 192. And then in order for me to solve this, all I need to do is divide both sides by 8. And I get x equals 24. All right, let's take a look at another example. Actually, scratch that. I forgot I was going to talk about CPCTC. So if you remember CPCTC from a previous chapter, that's where we said corresponding parts of congruent triangles are congruent. If I've got side lengths that are in a same scale factor between two similar polygons, then other side lengths are also going to correspond. And not just the sides of the polygons. When I say side lengths, I guess I should say segment lengths. So that could be in median length, an altitude length, even a mid-segment length. And also with that, what we care most about in this section are perimeters. So the perimeters are also going to go together with the same scale factor. So let's take a look at a little bit more involved example here. So in this case, I've got a pentagon here, and I've got a bigger pentagon here, and I want to find the scale factor of FGHJK to ABCDE. Now, one thing I want to be, I guess point out is that I don't want you to get tricked by just taking these and looking at them and going, oh, this can be 10 to 15, and that'll reduce to 2 to 3. Because the scale factor here in this statement, okay, is going to be driven by the way that the statement is written. And in this case, FGHJK is first. So this one goes first. And then ABCDE goes second. So the scale factor of this is actually going to be 15 to 10. And then when I take 15 to 10, that's going to reduce to 3 over 2. And then another type of question I might ask for you to figure out is what's this value of x here, okay? And in order to figure out the value of x here, once I've reduced the scale factor, I can use the scale factor to find x. So if I use the scale factor of 3/2, I need to figure out what goes with segment AE, or this x. So segment AE is in the first and the last slot here. So the number that's going to correspond with that is going to be in the first and last slot, which is FK, which is going to be 18. So I'm going to set up a scale factor of 3/2 equals 18 to x. And then when I cross multiply, 3 times x is 3x. 2 times 18 is 36. So I get 3x equals 36. And then when I divide by 3, I get x equals 12. So this value right here of x is actually going to be 12. And then the third part of this asks for the perimeter of this small figure. And you'll notice we don't know these other values. I don't know this, this, or this. But I can use the scale factor to help me find it if I add up all the side lengths here and use the scale factor. I already know my scale factor is 3/2, so then all I have to do is add up all these numbers. So if I add up 15 and 15 together, that's 30. If I add up this 18 and 12 together, that's also 30. So if I take 30 and 30, I get 60, and then add this 9, I get 69. So then I can set up a proportion. I can go 3/2 equals 69, because that's all of these added up together, over x. So then when I cross multiply, 3 times x is 3x. 2 times 69 is 138. And then if I divide both of these by 3, I get x equals 46. So the perimeter going around this one is 46. Now I could have added all of them up together. And if I would have added them all up together, or figured them out by adding them all up together, I'd have to do a bunch of calculations. I got to get this one, I got to get this one, I got to get this one. Whereas here, if I just use the scale factor, all I had to do was add up these and use the scale factor to find that. So it's kind of a shortcut. All right, last example. I want to find the perimeter of the small triangle. So the first thing I want to do is figure out what my scale factor is. So whatever goes with HJ here, which is my 8 feet, okay, that's going to be in my last 2 slots here, has got to be the number that's in the last 2 slots here, which is going to be BC. So in this case, my scale factor is going to be 24/8. And 24/8 reduces to 3/1. And then I can use my scale factor to figure out what the perimeter of the small one is by adding up all of these. So if I take 18 and 12 and add them together, I get 30, plus 24 is 54. So I can use that perimeter of 54 to find the perimeter of this small one. So I'm going to use my scale factor of 3/1 equals 54 to x. And then all I need to do to solve this is cross multiply. So 3 times x is 3x, and 54 times 1 is 54. So I've got 3x equals 54. And then to solve this, I need to divide by 3. So 54 divided by 3 is 18. So the perimeter of the small triangle is 18 feet. All right. So this moves us on to our assignment. So this whole section is just going to be this entire week. So on Tuesday, I just want you to do questions 1, 3, and 6. Don't send it to me, just do them. Then on Wednesday, I want you to do questions 4, 5, and 12. And then at that point, you can send me both of those assignments together in one email or one picture, hopefully on one piece of paper. And then on Thursday, I want you to do problems 9 through 11. Don't send it to me. On Friday, do problems 14 through 17. And then those 2 you can send to me on Friday as one email, one assignment. And we will focus just on you mastering section 6.1 this week. If you need to review this video or look at the problems that I have worked out, feel free to do so. And if you've got any questions, of course, just send me an email or give me a phone call, and I will help you. All right, thanks, and have a great rest of your day.